Okay, so today's topic is self-inductance. So we'll learn the meaning of self-inductance, we'll derive self-inductance and also self-induction. So what is basically self-induction first? Suppose that we have a coil. Suppose that we have a coil and suppose current is passing through the coil. And suppose current is not constant. Suppose current is depending on time. So if current depends on time, then magnetic field depends on current and current depends on time. So with change in time, I will change, then B will change. And if B will change, then the flux through the coil will also change. And if the flux through the coil will change, then there will be a induced EMF in the coil. So variation of current in a circuit. So variation of current in a circuit leads to the appearance of an induced EMF in the same circuit. This phenomena is called as self-induction. So suppose we have a circuit and a current I is passing through a circuit which is not constant. Then with change in current, flux through the coil will change, and with change in flux, EMF will induce in the coil. So the EMF is induced due to current in the same coil. So it is called as self-induction. Also, the more the current, the more will be the flux. So the more the current through the coil, so more will be the flux through the coil. So if we'll remove this proportional, then magnetic flux can be written to be equal to Li, where L is, what is L? Where L is constant of proportionality called as self-inductance and its SI unit is Henry. Now remember, whenever we remove proportional sign and put a constant, this L will not depend on phi and I. This L will depend on size and shape of the coil. Okay, and remember that induced EMF is equal to minus d phi by dt and flux is Li, L is a constant. So EMF will also be given by minus L di by dt, and it is self-induced EMF. Okay. Okay, suppose we have a question that if current in a coil is 10 ampere and flux passing through the coil is 100 Weber, find self-inductance. So I is given, phi is Li, so L will be 10 Henry. Let's take one more numerical. Suppose that when a current in a coil changes from 8 ampere to 2 ampere in 3 into 10 raised to power minus 2 second, induced EMF is 2 volt. What is the self-inductance? So E is minus L di by dt. We have E 2 volt minus an L written like that only. Change in current is final current minus initial current and time is given. So calculating this will get L to be equal to 10 raised to power minus 2 Henry. So these two are very important numerical which can come in your exam. So please remember this formulas. Okay. Okay, now let's come to a very important derivation of self-inductance of a solenoid. Suppose we have a solenoid with n number of turns, current passing through the solenoid is I, area of solenoid is A, area means suppose radius is R, then area will be pi r square and L is length. So magnetic field will be mu naught Ni, where n is number of turns per unit length, so n by L, and magnetic flux is NBA cos theta. So in the place of n, I have put n. On the place of B, I'll put value of B. On the place of A, I'll put A, and cos theta is 1. Suppose that I take a area whose area vector is in this direction and magnetic field also in this direction. So theta will be 0 and cos 0 is 1. So on the place of phi, if I put Li, I and I will cancel out. So L will depend on number of turns, area and length. That is size and shape of the coil. Okay, so this is self-induction and self-inductance. Please remember, if flux in a coil is due to current in the same coil, then that concept is called as self-induction. Okay.